Have you ever looked at a fossil and wondered what stories are locked inside rock that's millions of years old? Most people think fossils tell us everything about Earth's past, but here's the disturbing truth scientists don't want you to dwell on too long. If an advanced industrial civilization existed on Earth 100 million years ago, we might never find a single trace of it. In the next 30 minutes, I'm going to show you why everything you think you know about humanity's place in time could be completely wrong. And by the end of this video, you'll understand why some of the world's top scientists believe we might not be the first intelligent species to dominate this planet. But first, you need to know why the evidence for ancient civilizations wouldn't just be hard to find, it would be virtually impossible to detect. And that realization changes everything. So let me ask you this. If you wanted to prove humans existed 100 million years from now, what would you leave behind? You're probably thinking pyramids, cities, plastic, maybe some nuclear waste, right? That's what astrophysicist Adam Frank thought too, until a chance conversation with a paleoclimate scientist named Gavin Schmidt completely shattered that assumption. They were sitting in a conference room in 2017 discussing how we might detect alien industrial civilizations on distant exoplanets, when Schmidt asked a question that stopped Frank cold. How would you even detect an industrial civilization in Earth's own geological past? Frank later admitted he had no answer, and that moment of intellectual honesty gave birth to what's now called the Silurian Hypothesis, named after a Doctor Who episode where intelligent reptiles evolved before humans. Here's what makes this idea so unsettling. Earth is 4.5 billion years old, and modern humans have only existed for about 300,000 years. That's 0.0066% of Earth's history, which means we've been around for essentially a cosmic eye blink. Our industrial civilization is even younger, roughly 300 years old. That's 0.000066% of Earth's lifespan. Now think about this. If another species had a 100,000-year run of industrial activity anywhere in the previous 4.5 billion years, would we know? The immediate assumption is yes, of course, we'd find their ruins. But when Frank and Schmidt actually sat down and ran the numbers, what they discovered was genuinely frightening. But here's what nobody tells you about the fossil record. You think fossils are common, don't you? That's because every museum you've ever visited is filled with dinosaur bones and ancient shells, creating this illusion that the past is well preserved. But the reality is almost the opposite. Less than 0.01% of all species that have ever lived appear in the fossil record, and the conditions required for fossilization are incredibly specific. Rapid burial, lack of oxygen, mineralization over millions of years, and even then most fossils are destroyed by plate tectonics, erosion, and geological recycling. Here's the part that should make you deeply uncomfortable. The older the fossil, the rarer it becomes, not just because time destroys things, but because Earth actively erases its own history through subduction zones where oceanic crust gets pulled beneath continental plates and melted back into the mantle. The ocean floor itself is never older than about 200 million years because it's constantly being recycled, which means any evidence of coastal civilizations underwater, cities, or marine industrial activity older than 200 million years is simply gone, completely obliterated by planetary geology. Adam Frank put it this way: if you took all the fossil evidence of humans and compressed our entire existence into the geological record, future paleontologists might find a layer a few centimeters thick with strange chemical signatures and maybe a few scattered bones. But no buildings, no cars, no smartphones, nothing that screams advanced technology, the steel in our skyscrapers would rust into unrecognizable oxide within thousands of years. Concrete crumbles, plastics break down into microparticles that disperse, and even our most durable creations like nuclear waste would eventually be undetectable after tens of millions of years of geological processing. So what actually survives deep time? Not the things you'd expect. The answer is chemical signatures, isotopic anomalies, and changes in sediment composition, Which brings us to something absolutely critical that most people completely misunderstand about how we detect an ancient civilization. You wouldn't find their statues or their temples. You'd find the scars they left on the planet's chemistry. And when you start looking at Earth's geological record through that lens, some very strange patterns emerge that don't have easy explanations. The Paleocene thermal maximum that occurred about 56 million years ago saw global temperatures spike by 5 to 8 degrees Celsius in less than 10,000 years. Atmospheric CO2 doubled, ocean chemistry went haywire, and species died off in massive numbers. The geological signature looks remarkably similar to what we're doing to the planet right now with our industrial emissions. Elevated carbon isotope ratios, ocean acidification markers, nitrogen runoff signatures, all the fingerprints of large-scale energy consumption and agriculture. Now mainstream science attributes this to massive volcanic activity or methane release from ocean floor sediments, which is probably correct, but here's the uncomfortable question. Could you definitively rule out an industrial civilization as the cause, just based on the geological data alone? Frank and Schmidt's answer was no. You actually couldn't, because the chemical traces would look almost identical. And that's when things get really strange. Let me show you exactly what I mean. When humans burn fossil fuels, we release carbon that's been locked underground for millions of years. And that ancient carbon has a specific isotopic signature. It's depleted in carbon-13 compared to atmospheric CO2. When you pump billions of tons of this stuff into the air, you create a measurable spike in the ratio of carbon-12 to carbon-13 in everything. Ocean sediments, ice cores, fossilized shells, the whole planetary system records it. Now go back to that Paleocene thermal maximum 56 million years ago and look at the carbon isotope ratios in the geological layer from that period. You see the exact same anomaly, a huge spike in carbon-12 relative to carbon-13, meaning something was pumping vast amounts of ancient carbon into the atmosphere, just like we're doing now. Scientists explain this through natural processes. Methane clathrates destabilizing on the ocean floor and releasing greenhouse gases in a runaway feedback loop. But the Silurian Hypothesis asks a different question. If an industrial civilization had burned through their planet's fossil fuel reserves 56 million years ago, what would the signature look like? The answer is it would look exactly like what we see in the rock record. A sharp rise in atmospheric carbon, global temperature spikes, ocean acidification, mass extinction events, and then a recovery period as the planet's natural carbon cycle slowly rebalanced itself over hundreds of thousands of years. But it's not just carbon. Look at nitrogen. Modern industrial agriculture uses synthetic fertilizers created through the Haber-Bosch process, which takes nitrogen from the atmosphere and fixes it into ammonia. This process has doubled the amount of reactive nitrogen in the environment, and that leaves a distinct signature in sediment layers, elevated nitrate deposits, changes in nitrogen isotope ratios, eutrophication markers in lake beds. When geologists analyze sediment cores, they can pinpoint the exact moment. Industrial agriculture began in the early 20th century because the nitrogen chemistry changes so dramatically. Now here's where it gets weird. There are older geological periods where nitrogen isotope ratios show unexplained spikes that look similar to agricultural runoff, particularly during the Cretaceous period around 90 million years ago. Mainstream explanations involve ocean anoxia and changes in nitrogen cycling bacteria, which again is probably right, but could you rule out large-scale agriculture based solely on the chemistry? Not definitively. Then there's plastic. We produce about 400 million tons of plastic every year, and much of it ends up in the oceans where it breaks down into microplastics that settle into sediment. Future geologists will find a distinct plastic layer in the rock record marking our era, but plastic only lasts a few million years before breaking down completely into carbon and other elements. If a civilization 100 million years ago had used synthetic polymers, any trace would be long gone, degraded beyond recognition. leaving only subtle chemical anomalies that could easily be attributed to natural organic processes. Are you starting to see the problem? Every piece of evidence we think would prove our existence to future scientists either degrades completely or leaves behind signatures that can be explained by natural geological and biological processes, which means the absence of evidence for ancient civilizations isn't actually evidence of their absence. It's exactly what you'd expect if they existed long enough ago. Now let's talk about the Great Oxygenation Event, because this is where the Silurian Hypothesis gets truly mind-bending. About 2.4 billion years ago, Earth's atmosphere underwent the most dramatic transformation in planetary history. Oxygen levels exploded from nearly zero to about 20% in what scientists call the Great Oxygenation Event, and this wasn't a smooth, gradual process. It was catastrophically fast in geological terms, happening over just a few million years. The mainstream explanation is that cyanobacteria evolved photosynthesis and started pumping oxygen into the atmosphere as a waste product. And that's almost certainly what happened, but think about what that event actually represents. A single biological innovation fundamentally altered the planet's atmospheric chemistry, triggered a mass extinction of anaerobic life forms, caused runaway glaciation that nearly froze the entire planet in what's called Snowball Earth, and permanently changed the trajectory of evolution. It was Earth's first environmental catastrophe caused by life itself. Now ask yourself this. If a biological process like photosynthesis could alter the planet that drastically, what could an industrial technological civilization do? We've increased atmospheric CO2 by 50% in just 150 years. We've created a mass extinction event that's eliminating species at rates comparable to the asteroid that killed the dinosaurs. We've spread synthetic chemicals to every corner of the planet, including the deepest ocean trenches and the highest mountain peaks. And we've left radioactive isotopes in the atmosphere from nuclear testing that will be detectable for millennia. Our impact on Earth's chemistry is profound, and it's happening in a geological instant. And the critical realization is this. If we disappeared tomorrow and another intelligent species evolved 100 million years from now, they would see a thin chemical layer in the rock that showed a brief chaotic period of atmospheric disruption, temperature fluctuation, and extinction, but they probably wouldn't find cities or satellites or any physical artifacts. They'd see the scars, not the civilization. So how many times could this have happened? Earth has experienced at least 5 major mass extinction events in the last 500 million years alone. The Ordovician extinction 445 million years ago, the Devonian extinction 375 million years ago, the Permian extinction 252 million years ago, which killed 96% of all marine species, the Triassic extinction 201 million years ago, and the Cretaceous extinction 66 million years ago that ended the dinosaurs. Each of these events shows rapid environmental changes, atmospheric disruptions, and chemical anomalies in the geological record. And while we have natural explanations for most of them, like volcanic activity and asteroid impacts, the Silurian Hypothesis asks whether we'd actually be able to distinguish between a natural catastrophe and a civilization-induced collapse if we're looking at evidence that's hundreds of millions of years old. The answer is probably not, especially if that civilization only lasted a few 100,000 years before destroying itself or dying off. This is why the hypothesis is so unsettling. It's not claiming ancient civilizations definitely existed. It's pointing out that our methods of detection are so limited and the geological record is so incomplete that we simply couldn't know either way, which means the possibility remains open not as some fringe conspiracy theory, but as a legitimate gap in our scientific understanding. Let me give you the math that keeps astrobiologists up at night. The Fermi paradox asks why we haven't detected alien civilizations despite the billions of potentially habitable planets in the galaxy. And one of the proposed solutions is the Great Filter, The idea that there's some evolutionary or technological barrier that prevents civilizations from becoming spacefaring and long-lasting. Maybe it's the jump from single-celled to multicellular life. Maybe it's developing technology without destroying yourself. Maybe it's something we haven't even encountered yet. The terrifying possibility is that the great filter is behind us, meaning we've already passed the hardest step and intelligent life is incredibly common, or it's ahead of us, meaning something wipes out nearly every technological civilization before they can spread to the stars. But here's the thing nobody talks about. If the great filter is ahead of us and most civilizations destroy themselves shortly after industrialization, then statistically speaking, there should have been other attempts at intelligence on Earth before humans. Think about it. Earth has been habitable for about 4 billion years, and complex multicellular life has existed for over 500 million years. If the average technological civilization lasts, say, 100,000 years before collapsing, and if intelligence is reasonably likely to evolve given enough time, then over 4 billion years you could potentially have dozens of separate rises and falls of civilizations, each one leaving only faint chemical traces that get overwritten by geological processes. We might not be Earth's first attempt at intelligence. We might be attempt number 15 or 50, with all the previous iterations erased by deep time. Now I know what you're thinking. This sounds like wild speculation, and you're right to be skeptical, but consider what we know about intelligence on Earth right now. Humans aren't the only intelligent species on this planet. We share it with dolphins who have complex language and social structures, with octopuses who solve problems and use tools despite having evolved intelligence completely independently from vertebrates, with crows who craft sophisticated tools and pass knowledge across generations, with elephants who have culture and mourn their dead. Intelligence has evolved multiple times through completely different evolutionary pathways, which suggests it's not some cosmic fluke, but rather a useful adaptation that natural selection stumbles upon repeatedly given the right conditions. If that's true, then why would humans be the first and only species in 4 billion years to develop technology? The more likely scenario is that we're just the first one that happened to survive long enough in the geological record for our own scientists to recognize, or we're the current iteration in a cycle that's played out before. This is exactly why Adam Frank and Gavin Schmidt created the Silurian Hypothesis as a thought experiment. Not to prove ancient civilizations existed, but to force scientists to think about what biosignatures we should look for when studying exoplanets. If we can't even detect industrial civilizations in our own planet's deep past, how are we supposed to recognize them on worlds orbiting distant stars? The answer is we need to look for atmospheric and geological signatures that can't be explained by natural processes. Weird combinations of industrial pollutants, simultaneous spikes in multiple chemical markers, isotopic ratios that don't match volcanic or biological sources. Basically the same kinds of anomalies that would mark our own civilization in the rock record millions of years from now. And when you start looking at Earth's history with that framework, some genuinely strange things start appearing that don't quite add up. Let me show you 3 geological mysteries that have never been fully explained. First, the Cambrian explosion. About 541 million years ago, nearly every major animal phylum suddenly appears in the fossil record over a period of just 10 to 25 million years, which is incredibly fast in evolutionary terms. Before the Cambrian, life was mostly simple and soft-bodied. Then suddenly you get complex predators, hard shells, eyes, sophisticated nervous systems, ecosystems with multiple trophic levels, all appearing almost simultaneously. The standard explanation is that rising oxygen levels and evolutionary arms races triggered rapid diversification. But some researchers have pointed out that the speed and coordination of this event is unusual. You see simultaneous innovations across completely unrelated lineages, as if something fundamentally changed in the environment that made complexity suddenly advantageous. Could it have been a previous civilization's collapse that reset the planets chemistry and created new ecological niches? Almost certainly not. But the point is the data doesn't completely rule it out either. Second, the Permian extinction 252 million years ago, the worst mass extinction in Earth's history. It killed 96% of marine species and 70% of terrestrial vertebrates, and the kill mechanism is still debated. The leading theory involves massive volcanic eruptions in Siberia releasing enormous amounts of CO2 and sulfur dioxide, triggering runaway greenhouse warming, ocean acidification, and anoxia. But here's the odd part. The extinction happened in multiple pulses over about 60,000 years with strange patterns in the fossil record. Some species went extinct, then briefly reappeared, then went extinct again. Chemical signatures show wild swings in ocean chemistry that are hard to explain with volcanism alone. There are iridium anomalies suggesting possible asteroid impacts. Organic carbon isotopes show patterns consistent with massive ecological disruption beyond what you'd expect from volcanic CO2. None of this proves anything other than natural causes, but it shows how complex and chaotic these events were, and how difficult it is to reconstruct exactly what happened from fragmentary evidence buried under 252 million years of geological change. Third, and this one is really strange, there are fullerenes in the geological record. Fullerenes are molecular structures made of carbon atoms arranged in hollow spheres or tubes, basically natural nanoparticles. They form under very specific high-energy conditions like lightning strikes, meteor impacts, or combustion. In the 1990s, scientists found fullerenes in rock layers associated with the Permian extinction and other major geological events. And some of these fullerenes contain trapped noble gases with isotopic ratios that didn't match Earth's atmosphere or any known meteorite source. The origin of these fullerenes is still debated. They might come from some unknown type of cosmic impact, or they might form through exotic volcanic processes we don't fully understand. But the point is we keep finding weird chemical artifacts in the deep geological record that don't fit neatly into our models. Now, I'm not saying any of this is evidence of ancient civilizations. I'm saying the geological record is far stranger and more incomplete than most people realize, and our ability to interpret events from hundreds of millions of years ago is severely limited by the fact that most evidence simply doesn't survive. So what does this mean for us? Here's what the Silurian Hypothesis is really about. It's a mirror. By asking whether we could detect a previous industrial civilization on Earth, we're forced to confront what our own civilization will leave behind. Right now, we're conducting a planetary-scale experiment with our atmosphere, our oceans, our biodiversity. And we're doing it with almost no understanding of the long-term consequences because we have no historical comparison. We've never seen an industrial civilization rise and fall. We only know our own 300-year sample size, which in geological terms is meaningless. But if previous civilizations did exist and collapse, then the thin chemical layers they left behind are warnings written in stone that we're too blind to read. Think about what we're creating right now. A carbon isotope spike that will be visible for millions of years, a mass extinction event that's eliminating species faster than any natural process except asteroid impacts, plastic and chemical pollution spreading to every ecosystem on the planet, radioactive isotopes from nuclear testing scattered globally, and potential future signals like industrial nanoparticles, synthetic biology markers, and technological waste that will leave signatures we can't even predict yet. This is our legacy, a brief, chaotic pulse in Earth's chemical record that future geologists might attribute to volcanism or natural climate variation because they won't have the resolution to see the cities and the cars and the politics and the choices that created it. And here's the most sobering part. If a civilization 100 million years ago went through the same process we're going through now, if they had their own version of the Industrial Revolution and fossil fuel dependence and climate disruption, and if they failed to transition to sustainable systems and collapsed, we would never know. Their story would be lost, their achievements erased, their mistakes unlearned, and we'd be doomed to repeat them without even knowing we're following a script that's already been performed. That's the real horror of the Silurian hypothesis. Not that ancient alien reptiles built pyramids or that Atlantis was real, but that intelligence might be common and self-destruction might be the norm, and the universe might be filled with planets that have tried and failed over and over to build lasting civilizations, each one leaving nothing but faint chemical scars that fade into geological noise. So let me bring this back to the question we started with. Were we the first civilization in the solar system? The honest answer is we don't know, and we probably never will. The geological record is too incomplete, the timescales are too vast, and our detection methods are too limited to say with certainty that no previous industrial species ever existed on Earth. But absence of evidence is not evidence of absence, especially when the evidence you're looking for wouldn't survive the conditions you're searching through. What we can say is this: if we want to be a civilization that lasts, that breaks the cycle, that doesn't become just another unreadable chemical layer in the rocks, we need to think in geological timescales, not quarterly earnings reports or election cycles. We need to recognize that everything we do is being recorded in the planet's chemistry, and that record will outlast our species by hundreds of millions of years. The question isn't whether we'll leave a mark. We already have. The question is what kind of mark it will be. Will future geologists see a brief, catastrophic spike in industrial pollutants followed by collapse and recovery? Or will they see something different, a civilization that recognized the warning signs, that transitioned to sustainable systems, that spread beyond a single planet and left intentional markers in the geological records saying we were here, we understood the stakes, and we chose to survive? Right now, we're writing that story in real time, and we don't know how it ends. The Silurian hypothesis isn't just about ancient mysteries, it's about recognizing that we're not special, that intelligence and technology don't automatically lead to long-term survival, and that the universe might be littered with failed experiments just like us. But it's also about hope, because if we can ask these questions, if we can look at deep time and see the fragility of civilizations, then maybe we're smart enough to break the pattern. Maybe we're the ones who finally get it right. So here's what you need to take away from this. Question everything you think you know about humanity's uniqueness. Recognize that our entire history is a single data point in a 4 billion-year experiment. And understand that the choices we make in the next few decades will determine whether we're remembered as the civilization that survived or just another chemical anomaly that future scientists attribute to volcanoes. If this video made you rethink humanity's place in deep time, subscribe and leave a comment telling me what geological mystery you want explored next. Your engagement is what separates surface-level content from the kind of deep investigation we do here. And every like tells the algorithm to show this to people who actually care about existential questions instead of random scrollers. Now go think about what legacy you want to leave in the rocks.